Okay, in the previous set of videos then we took the standard two standard simultaneous equations, um, equation 1 and equation 2, and we came up with, or we showed that for any general case of two simultaneous equations, we could use these second order determinants, and we came up with, at the end of the last video, x over this determinant equals minus y over this determinant, which equals 1 over this determinant. Okay, so our variables are x, y, and then these are units, or 1. Okay, so we have come up with these determinants. This determinant here, b1, c1, b2, c2, if we cover up, if you like, or if we ignore the a part of this, as they stand, these coefficients b1, c1, b2, c2 are as they appear in this region here. Okay, we then look at the y, the ones that are related to the y variable, and those coefficients are, again, if we cover up this section of the equations, we have a1, c1, a2, c2. So a1, c1, a2, c2 appear down here, and this is negative. Okay, so we will find that these alternate plus, minus, plus, and that's the key to working these out. And then finally, for the variable which is 1, the units section of the equation, again, if we ignore the c coefficients, we're left with a1, b1, a2, b2, a1, b1, a2, b2 for our determinants down here. And we can build up these set of terms, and we could call this, we can call it the determinant, which is often represented by this delta, Greek letter, capital letter delta, and let's call that x. So that's the determinant x. This one we'll call it determinant y, and this one determinant units. So we have x over determinant of the which we'll call the determinant of the x is equal to minus y over the determinants, which is equal to 1 over those determinants. Okay, and that's a general case. And in the next set of videos then, we're going to, instead of looking at these second order determinants, we're going to look at determinants of the order 3. Okay, so we are going to look at a situation where we have a1, b1, c1, a2, b2, c2, a3, b3, c3. Okay, and we might want to use this for determining, or to solve simultaneous equations, say for example 3 simultaneous equations with 3 unknowns. So this might take the form a1 x plus b1 y plus c1 z plus d1 possibly equals 0, and we might have 3 equations in these 3 unknown variables x, y, and z. Okay, but we're not going to relate it specifically to the simultaneous equations. We use the simultaneous equations to show why these things are useful, these determinants are useful, but we need to move on and see how we deal with determinants of a higher order, in particular the third order determinants. Okay, so we need to establish a concept of something called a minor of, so the minor of A1. For example, if we take A1 is common to this row and this column, A1's minor then will be this group of coefficients here, B2, C2, B3, C3. Okay, so the minor of A1 is obtained in that fashion. Similarly, if we want the minor of B1, B1 is common to this row and this column, so its minor is of the form A2, C2, A3, C3. Okay, and then similarly again, the minor of let's say B2 this time, we're interested in this one, that's common to this column and this row, so B2's minor is A1, C1, A3, C3. Okay, and we can work through we simply ignore the rows and the columns which are containing B2, and our minor for B2 is determined by the remaining coefficients. So to evaluate the determinant then of a third of the third order, so this determinant here, we simply take the top row of that the top row of coefficients and multiply them, each of those, by its individual minor. Okay, and give the terms the plus or minus sign alternately. Okay, so for example, the determinant of this, so that this determinant is equal to this one, A1, multiplied by its minor, which is B2, C2, B3, C3, and then we subtract, so it goes plus, again in similar fashion to plus, minus, plus, we alternate plus, minus, minus B1, determinant of its minor, so that the minor of B1 is A2, C2, A3, C3, and then plus C1, determinant of its minor, which is A2, B2, A3, B3. Okay, so that the determinant of this, or this determinant, this third order determinant, is given or is evaluated using this method. And then of course we know how to calculate these values, because we know how to calculate these determinants. If you remember, it's plus this diagonal minus this diagonal, so that becomes A1 times B2C3 minus B3C2. Okay. And we could in fact expand that determinant along any row or column, as long as we remember that the sign alternates, so plus minus plus minus plus minus plus minus plus for that third order determinant. So we could, for example, come down the B1 column and have B1 because it's minus B1, it's this one here, determinant of its minor A2 C2 A3 C3 plus this time B2 and then the minor of that is A1 C1 A3 C3 minus B3 determinant of its minor, which is A1 C1 A2 C2. Okay, so that's how we evaluate a third order determinant. And as I said, we could use that to go on to solve a set of three simultaneous equations in three unknowns. We will leave that there for now, and we'll go back to looking at matrices and how we can use that in our matrix methods for our stiffness matrices that we've been looking at. Okay.